Welcome to the GameDev Tavern, a place to chill and hang out as we create video games from scratch together. My name is Nicholas, and I've been a software engineer for more than 20 years. I've been spending the last 8 years leading engineering teams working on Gmail at Google. In this tutorial series, we'll be building a beat-em-up pixel art game in Godot. This tutorial is aimed at beginners and intermediate game developers. If you're just getting your feet wet in game development, this is a great place to start. And if you're already familiar with Godot, you'll still probably find some interesting concepts and design patterns you can reuse in your own games. This series will be pretty long, but it will be broken into episodes of roughly 30 minutes each. If you're interested in playing the game before getting started, I've included a link in the description below. Hop over on itch.io and spend a few minutes punching a few faces. You may find it therapeutic after a long day of school or work. And with that intro out of the way, let's go ahead and get started. First things first, you'll need to install Godot if you haven't done so already. Hop over to godotengine.org and download the latest version of Godot on your hard drive. Once installed, go ahead and start the game engine. So when you first load up Godot, you'll be greeted with this welcome screen. Go ahead and click on Create New Project. We need to give it a name. I'm going to call mine Fist of Fury. Feel free to call yours whatever you want. And then choose the folder where your project is going to live on your hard drive. Finally, you'll be asked to pick between 3 renderers: Forward Plus, Mobile, and Compatibility. So Forward Plus is perfect for advanced 3D games. Mobile is meant for smaller and more optimized games. We'll actually be picking Compatibility here, as we'll be publishing the game on itch.io, and this is the only renderer that currently supports web exports. You can leave the other options by default. Go ahead and click Create and Edit. Welcome to the Godot interface. As you can see, there's a lot to unfold on this screen. We'll go ahead and take it slow initially. First, we'll simplify the editor a bit. Because we're building a 2D pixel art game, we actually don't need any of this 3D stuff to be displayed. Godot provides a really convenient way of customizing its user interface by clicking on Editor, Manage Editor Features. We'll go ahead and create a new profile where we'll do a bit of customization. Let's call it 2D. And then we'll get rid of a couple of things. First, we won't need the 3D editor. We won't be using the asset library. And then if you scroll down to Node, these are all the UI stuff we'll be keeping. Node 2D we'll be using constantly, but we'll get rid of the Node 3D. Go ahead and press OK. Next, you'll need to import all the assets needed to build the game. I've included a link in the description below. Just go ahead and download it, then unzip it on your hard drive. You'll then need to drag and drop the entire assets folder directly into Godot. These assets contain all of the pixel art, music, sound effects, and fonts that we'll be using in our game. Before getting started, we'll take a quick minute to introduce 4 key concepts that are important to understand how the Godot game engine works. We will be revisiting these concepts throughout the series. First, let's talk about scenes. A game is comprised of complex objects called scenes. If you're familiar with Unity, this is very similar to prefabs and are simply reusable objects for the game. A scene can be as simple as a main menu and can be as complex as a game character, an entire level, or pretty much anything you can think of. A scene will usually contain a script that defines its behavior. Second, we have nodes. A scene is composed of one or multiple nodes. Nodes are the game's smallest building blocks. They are organized in a tree structure as part of each scene object. For example, our character scene will be a tree that contains a node to show the sprite image, another node to show the shadow image, a node that facilitates animations, etc. Each node has a specific type which provides different functionality and can be configured through a set of properties. For example, a node of type Node2D simply represents a point in a 2D space, while a more complex node of type Audio Stream Player provides the ability of playing audio files. Godot provides a very large library of predefined node types, which we will be using to build the game. When these nodes are active, they are processed on every single frame to see how they evolve throughout the gameplay. Third, let's talk about the scene tree. When zooming back, all of those scene objects are composed together in a big tree that represents the game. These objects are dynamic and continuously evolve throughout the gameplay in the scene tree. Lastly, we have signals. Similarly to how newsletters in the real world are sent out to people who are subscribed to them, nodes can become publishers and emit their own signals to communicate information to other nodes that are subscribed to receive that information. This allows for some very flexible communication and decoupling in the code, because nodes don't need to keep track of who they are communicating with. They simply emit signals that are captured by whoever is listening to them. Don't worry if you don't grasp these concepts right away. We'll be revisiting them constantly as we build the game together. So this is our scene tree, and it will hold all of our game objects. It's currently empty, so we need to create a scene that will be the root of the entire scene tree. A common practice here is to click on 2D scene, meaning that our root scene will be a very simple point in our 2D space. You can see the properties here on the right-hand side. We will keep it at the position 0, 0 to represent the world origin. Over time, this scene will contain every single object in the game as its own children. We'll need to give it a name. Go ahead and press F2 on your keyboard to rename it, and let's go ahead and call it World. It represents the container for all future scenes where the game will take place. Now go ahead and press Ctrl S to save the scene, and let's keep the current default name and location. Okay, we're ready to start the game. Let's go ahead and do that by pressing F5. So the first time we try to run the game, Godot asks us which scene to run by default. The scene we just built will contain all of the game objects, so let's go ahead and click Select Current. Alright, well, I'm sure you're quite impressed with the game so far. Time to add some graphics. So we'll start by creating our first level. Click on the plus sign here at the top to create a new scene. Similarly to the world scene, we'll make this a 2D scene. Let's go ahead and press F2 to rename it. And in beatemup games, it's common to call these levels stages that have checkpoints. So let's call this stage. Press Ctrl S to save. And this time we're going to be creating a new folder called Scenes. And within Scenes, we're also going to create another folder called Stage. Okay, let's keep it here and click on Save. So our level will be a scene that will contain all of the backgrounds, enemies, and all sorts of props. And because it will end up containing a ton of objects, it's always nice to be well organized from the start. So similarly to how you'd be using folders to organize your files on your computers, in Godot we can use basic 2D nodes to serve as folders or containers for other objects. We'll go ahead and add our first child node to be used as a container. You can add a new node by clicking this button here, or by using the shortcut Ctrl A. We'll go ahead and select Node 2D, which is just a point in our 2D space. Let's go ahead and rename this Backgrounds. We'll have several images to create our final background. Now to add a sprite, we'll simply need to add a new node of type Sprite2D. So let's go ahead and press Ctrl A, type Sprite2D, and select the node. We then need to specify which texture to use. Let's go into the file system and locate inside Assets, Arts, Background, Street Background, and go ahead and drag and drop this image all the way until the texture property. We'll do one last thing, which is we don't want the background to be centered. So let's go ahead and click on Offset and uncheck this button here. Go ahead and press Ctrl S to save the scene. Remember that scenes are reusable objects, but it's not enough to just create scenes. We also need to add them or instantiate to our world scene where the game is actually happening. So let's go back to the world scene here. And you can instantiate a predefined scene by either clicking this button or by using the keyboard shortcut Ctrl-Shift-A. Here we'll select our stage and press Open to add the scene as a child scene to our world view. Go ahead and press F5 to start the game. Okay, I would say it's looking slightly better, but it's still far off from where we need to be. Because we're building a pixel art game, we'll need to upscale the resolution of the game and adjust a few settings when the game is played. Hop over to Project Settings by clicking Project Settings. There's a lot to unpack here, but we only need to cover a few of those options over time. First, let's fix the resolution. Click on Display Window. Our game's resolution is going to be 100 pixels width by 64 pixels height, so let's enter these in our viewport width and height. Let's go ahead and start the game. As you can imagine, that resolution is super tiny and you probably need a really good eyesight to enjoy the game. Now, when we try to resize the window, Godot doesn't currently do anything. And ideally, Godot would stretch the original canvas to fill the size of the window. Let's go back to Project Settings. In the Stretch section, we'll go ahead and set it to Viewport. This will stretch the game in a way that there is still a correspondence between the sprite pixels and the screen pixels. We'll also set the scale mode to integer. This means that the screen size will always be an integer multiple of our game resolution, and this will ensure that all of our pixels remain nice and square. Now let's go ahead and run the game. You can see that it behaves correctly when you resize the window. Ideally, we don't need to have the player manually resize the window, so we'll need to adjust one last setting. In Project Settings, go ahead and enable the Advanced Settings, and here we can override the width and the height of the window. Let's set this to 1000 times 640. Go ahead and press F5. Okay, this is looking much better. One final tweak we need to do is to change the default compression of textures. By default, Godot compresses every texture, which makes 2D pixel art look a little bit blurry. I don't know if you can see it here on the screen, but you'll definitely see the difference as we remove the compression. Go back to Project Settings, and then scroll all the way down to Rendering Textures. And here at the very top, for default texture filter, set this to Nearest. Go ahead and click Close. And if you zoom in a little bit, and we're going to hit Ctrl-Z to undo this latest change, and then Ctrl-Shift-Z to redo, you can see as we go back and forth the difference between having that compression on or off. Okay, we're all set up to get started and adding a character. Go ahead and create a new scene. Once again, we'll need to pick a type of node which will be best suited for a playable character. So far, we've introduced two types of nodes, the Node 2D, which represents a point in space, and the Sprite 2D, which represents a texture in space. Playable characters are physical objects that can collide with each other and with the world around them. In Godot, every physical object that needs to support collision detection and respond to physics need to be of type PhysicsBody 2D. Godot actually offers 4 different types of node that we can choose from, and they each offer a different set of functionality. We'll take a quick minute to talk about each of these and which one you should pick depending on the object you're creating. The first and most complex type is called the Rigid Body 2D. This is a 2D physics body that can only be moved by physics simulation. We never set its position in the script. In order to move it, we need to apply a physical force like wind or gravity. And then Godot will take care of doing all of the complex math to calculate the resulting movement, collisions, and so forth. Our game won't actually be using any physics forces at all, so we won't be spending any time talking about this node in this tutorial. When you're not using any physics forces or doing any sort of physics simulation, but you still need to do collision detection, you're left with 3 options in Godot. For each of those 3 options, the position of the objects will need to be set manually through code on every single frame of the game. The simplest of those 3 is called the Static Body 2D. This is a very simple physical object that typically serves as a simple collider and whose position remains fixed throughout time. It's best used for things like walls and floors. If we were to move a static body to this position throughout code, its body wouldn't actually affect other bodies in its path. Instead, it would simply teleport through to its new location. Now, this isn't a very usual behavior, so typically when using static body 2Ds, those never move and remain static. In our game, we'll be using static body 2Ds for our background wall, our screen limits, and other static props like the destroyable barrels. Most of the time though, physical objects actually need to affect other bodies when they're moved around. For example, if you're building a moving platform, it will need to support and carry the physical objects that sit on top of it as it moves through the level. For this type of behavior, Godot provides two remaining options. The first option is called a character body 2D. A character body 2D is a node that has a ton of built-in functionality for advanced slope and wall detection when it moves. This makes it very convenient to do things like sliding against walls or physical shapes that have rounded edges. It's super handy to make user-controlled movement very smooth with very little code. If you don't need any of this advanced slope and wall detection when the object moves, but you also don't want the object to teleport through other objects the way that a static body does, you can just fall back on using animable body 2D, which is simpler to configure. In our game, we will only be using static body 2Ds for static environment and props, and character body 2Ds for our player character and for our enemy characters. Finally, each body will need to define a physical shape attached to it so that Godot knows where and how to perform collision detection. Because our game uses a top-down perspective, each physical body will be best represented by circles and ellipses at the feet of the physical objects. This will allow us to simulate depth as physical objects go in front of each other. Alright, I know that was a lot of information, and it's absolutely fine if you don't remember it all. Godot actually makes it quite easy to swap one type of physical body for another, so sometimes trying various options is just the best way to know what fits your game better. In any case, we'll be using a character body 2D type for our characters. Let's go ahead and call this scene character, and let's go ahead and save it into our scenes folder, and then we'll create a new folder called characters. And we'll just save our scene here. As you can imagine, there's going to be a lot in common between the character controlled by the player and the enemy characters. They're all human characters with common properties like health points, movement speed, attack speed, and so forth. And they also share similar behaviors like the ability to walk, to attack, and use weapons. So if we were to create individual scenes for every single type of character, we'd probably end up repeating the same process multiple times. Godot has a much better way of working with objects that share common logic. This character scene that we just created is going to be a bare bones object that will contain all of the logic and behavior that is common across all the characters in the game. If something is uncommon for all characters, we'll just leave it out for now. Then we'll go ahead and create new scenes that derive from the original. And these scenes will only contain the variations and differences from the parent object. In programming, we call this concept inheritance, and it is a core part of how to build games in Godot, as well as object-oriented programming in general. This character scene will contain all the nodes that are common to the player and the enemy characters. Let's add some of those nodes. First, all players will have a shadow image, so let's go ahead and add a new sprite node by either hitting Ctrl A or pressing this plus button here. Let's go ahead and find this sprite node. Let's rename it Shadow Sprite. And then in the art folder, if you look under characters, go ahead and drag and drop the shadow.png image all the way to the texture property on the right hand side. Okay, next, all characters will have a main sprite image. So we can also create another sprite 2D image and call it character sprite. We'll go ahead and select the character first so that the node is attached to the root of the tree. However, the texture is going to be different for each character, so we won't set it right away. As you can see, there's a warning sign up here that says that the node has no shape. And as we mentioned earlier, each physics body needs to have a collision shape. So let's go ahead and add a collision shape 2D node. And finally, all characters are going to have some animations. Godot actually has a really handy node to handle animations called Animation Player. Go ahead and click back on the root, Ctrl A, and let's go ahead and add the Animation Player. We will also start writing the code for behavior and properties that are common across all the characters in the game. Choose the character as the root, and then click on New Scene at the top. We'll go ahead and keep the current values and click Create. Okay, there's a ton of code that Godot writes for us. We're actually going to remove it all except for the first line. That first line simply indicates the type of node that is our scene. It means that we'll have access to all of the handy properties and functions from the character body 2D class to move and slide the body against other colliders. However, we do want to specify a few common properties to all characters, such as the health, the damage they inflict, the speed, and so forth. We're going to be using the export annotation, which is a handy way of Godot to have all of those properties surface up in the editor. Let's go ahead and add a variable for health, and this is going to be a number of hit points, so it's going to be an integer. Let's go ahead and add a property for damage. We'll also make that an integer. And finally, let's go ahead and add a property for speed. We'll probably want that to be a little bit more precise, so we'll go ahead and use a floating number. When you go ahead and save, you will see that those three properties now appear on the right-hand side, which makes it very convenient to make changes to those values without having to go back in the code. Now that we have created this common class, we can create deviations of that scene to create our player and enemy scenes. We do this by clicking on Scene, New Inherited Scene. We'll need to indicate which scene to inherit from, and in our case, we'll just pick the character scene as the parent. We'll see that this scene resembles its parent quite a bit. It has the same name, but as you can see, it's a new scene that still hasn't been unsaved. Let's go ahead and rename this to player and save it to the same folder where the character is. Let's try a few things. Let's go back into the parent scene and make some changes to some of the properties that we created earlier. For example, let's go ahead and set the speed to 5. Press 5, enter, make sure to save the parent scene first, and then navigate to the child scene, and you should see that the property change has propagated all the way to the children. However, the reverse should not be true. If I make some changes to the child nodes, for example, I'm going to set the damage to 10, and hit enter, whenever I go back to the parent, you'll see that this has not propagated. This is a very important rule of inheritance. There's one change that we'll want to make here in our parent scene that we'll want to propagate to all of the children. Typically, when we do pixel art, we want to avoid having Godot try to center things, as it tends to mess up the alignment of a sprite if it's not using even dimensions. Let's go ahead and select the shadow sprite and uncheck the centered here, and then let's manually set the offset to -7 pixels 0. Go ahead and press save, and that change should have propagated all the way to the player. Now we'll be setting all of the properties that are specific to the player characters and won't be shared with the enemy characters. For example, here we'll give it a health of 30, 4 points of damage, and a speed of 35. We'll also set the main sprite for the character. You can locate it inside the art folder, character, and player. Make sure to select the character sprite node and then go ahead and drag and drop the player.png image to the texture. As you can see, the sprite contains all the frames for our character. This sprite sheet contains 10 rows and 10 columns, or a total of 100 sprite frames. Godot provides a handy way to cut the sprite sheet into individual sprites. We're going to go ahead and click on the animation property and set the number of horizontal frames to 10 and the number of vertical frames to 10. And as we zoom in here, you will see that we can now indicate which frame we want to be using this frame property here. We'll also want to change the location of the image. In our game, we'll need to sort sprites so that they can go in front or behind each other depending on the depth and where they are on the map. In order to facilitate this, we're actually going to establish a convention that every object should make contact with the floor at the axis origin right here. By following the same convention for every single object in the game, Godot will actually make it really easy to do sprite sorting. Click on Offset, remove the offset, and we're going to set it manually to -24, -48. Finally, we'll want to define which shape to use for our collision shape 2D node. We're going to go ahead and use an ellipsis. Select the node, and then in Shape, click on Create New Capsule Shape. Let's go ahead and rotate it by 90 degrees, and then we'll set it so that it fits right at the feet of the player. We can set the radius to 2 and the height to 12. Let's go ahead and save. We've now created a player scene that we can reuse wherever we want. Let's add it to the world scene. Click on Instantiate Child Scene, select the player, and click on Open. We'll go ahead and zoom in a bit using the scroll wheel, and then we'll move the player to the center of the screen. Press F5 to make sure that it works properly. Okay, let's make our player move. Hop over back into the character scene and open the script that we had created earlier. On each frame, Godot will go through every single node in the tree and process their code. We can add logic to be processed using a special method called process. This contains an argument called delta. You're probably wondering what that is. Well, let's try something simple. Every time this function is executed, which is going to be on every single frame, we'll move the character by 1 pixel to the right. Press F5. You should see the character move to the right. While it may look the same, what you're seeing on your computer is actually different than what I'm seeing on my computer. The problem here is that faster computers will go through the process method more times than slower computers. Let's say you have a much faster computer than mine and Godot is able to go through this method 50 times per second, which means you'll be moving at 50 pixels every second. On my slower computer, Godot may only be able to run through this about 10 times per second, so I'll only be moving by 10 pixels every second. That's not something you really want. This is where delta comes into play. Delta is the amount of time that the last frame has taken to render. We can print it out to see the value. The value here is 0.01666, which is 1 divided by 60, or 1/60th of a second. So what happens when we multiply our movement by delta? Well, so on a fast computer, because we'll have gone through this 50 times per second, and delta equals 1 over 50, we're going to have, after 1 second, we're going to have position equals 50 times vector 2.right, and then let's go ahead and replace delta by 1 over 50. And some simple math will tell you that this is just vector 2.right, which means that we used to move at 1 pixel per frame, and we're now moving at 1 pixel per second. What happens on a slower computer? Well, on a slower computer, we may only be going through this 10 times per second. So delta is only equal to 1 over 10. So after 1 second, position equals, we'll have gone through this method 10 times. Vector to the right times delta, which is equal to 1/10. And as you can see, the result here is the same. Vector to the right, which is 1 pixel to the right. The slower computer and the faster computer now move by the same amount every single second. So every time we have movement expressed in pixels per frame, we'll actually want to use delta to transform it into pixels per second so that our movement becomes independent of frame rate. Let's go ahead and delete all of this for now. We'll actually want the player to control the character. Now, games often support more than one input method, for example, allowing players to choose between playing with a keyboard or with a gamepad. But the code for what happens when you press a key on a gamepad or on a keyboard is going to be the same. So rather than having us write the same code multiple times, in Godot we'll be defining a set of actions, such as attacking or jumping, and map those actions to various keys or gamepad buttons. Then we'll only have to write the code once for each of those actions. Hop over to Project Settings, and here you'll see an Input Map tab. This lists all of the actions supported in the game. Godot actually has a few predefined actions that you can see by clicking on the Show Built-in Actions here to the right. This includes things like handling the directional keys, like UI left, UI right, and so forth, entering and canceling stuff in the UI. Let's go ahead and turn this off, and we'll go ahead and add 2 new actions. Add new action, type attack, and press enter. Here we'll be pressing the plus sign to assign either a key or a gamepad button, and we're going to assign this to the C key. So press C on your keyboard. Let's add a different action for jumping. Click on add new action, type jump, then enter, plus sign, and we'll go ahead and press the X key. Okay, we'll now want to use that in the code. We can reuse those actions for the movement of our character. For example, here we'll use a built-in function called isActionPressed. Now, whenever you press the right key, you will see the character move to the right by 1 pixel per second. This is really slow, so we'll go ahead and use the speed property that we defined earlier to make the player go faster. The player now moves by 35 pixels per second whenever we press the right key. The natural next step will be to write the same code for all 4 direction keys. Let's try it out. Do you notice anything weird? The player actually goes much faster in the diagonals. Let's hop over to the whiteboard. When we press the right key, we'll be moving to the right by 1 pixel. When we press the up key, we'll be moving to the top by 1 pixel. When we press both keys at once, we'll be both moving by 1 pixel to the right and 1 pixel to the top, which means that the distance covered is the one represented by this third green line. And as you can see, this is about 40% longer than the other two. What we need is for our player to travel by 1 pixel per second, independent of the direction picked. We'll want to shorten all of those distances so that they're all equal to 1 pixel, which is also equivalent to constraining them to a circle that has a radius of 1 pixel. Reducing a vector to a length of 1 is also called normalizing a vector. So Godot actually has a very handy way of capturing this vector of length 1 by using the method input.getVector. And this requires to specify a couple of actions for the positive and negative directions. And this will create a vector of 1. So rather than have us specify those vectors and calculate what it's like when we have a diagonal vector, this will always return a vector of 1 that corresponds to the directions that are being pressed. So all we need to do now is to move the position according to this new direction times delta times speed. We'll get rid of all of this and press F5. So we're currently manually setting the position every single frame. However, this leaves it up to us to see if a player can actually move to a specific position. The main reason we picked a character body 2D type is to get some help in doing all of this collision detection and only move the object where it should. We can look at the help contents and the definition of this class by clicking on character body 2D and holding Control on the keyboard. This class provides a high-level API to move objects with wall and slope detection using a method called move and slide. Let's go ahead and click on it. Move and slide moves a body based on velocity, and it does all of the collision detection automatically for us. Let's go ahead and click on velocity. Velocity is the speed at which the object is going to be moving in pixels per second. This is already very similar to what we've been doing in our code. So let's go ahead and rewrite it so we can use the velocity and the move and slide APIs from the character body 2D type. We're now using the built-in APIs from character body 2D, and as we'll see later, this already provides collision detection, even though we're not doing any right now. Alright, this is going to be it for this episode. We covered a lot of basic concepts in the past half an hour. So if you're new to Godot, hopefully you're not feeling overwhelmed. But if you have any questions regarding this lesson, please add a comment below and I'll do my best to respond quickly. If, on the other side, you're a seasoned veteran, you're probably watching this video at double speed. But don't worry, we're going to reach cruising speeds pretty soon. The GameDev Tavern is a brand new YouTube channel, so if you do like this sort of content and want to see more tutorials, well, you know what to do. Use those like and subscribe buttons at the bottom to help the channel grow. Once I reach 1,000 subscribers, I'll have you pick what type of game you'd like to build next, either in Godot or in a different game engine. Time to take a quick break, and I hope to see you in the next episode. Cheers!